Hello everyone, welcome to ChemConnect. Myself Anisha Suresh, PhD student from IIT Bombay. I am super excited to have you join me today for a fascinating journey into the world of chemistry. In this video, we will be discussing an intriguing chapter from the world of chemistry, that is classification of elements and periodicity in properties. We will be focusing on a crucial piece of history that paved way to our modern understanding of elements. Yes, we will be talking about Dobereiner's Triads. Let's begin with Class Plus 1 Chapter 3 Classification of Elements and Periodicities in Properties. Coming to the genesis of periodic classification. We know the elements are the basic units of all types of matter. With such a large number of elements, it is very difficult to study individually the chemistry of all these elements and their innumerable compounds individually. To ease out this problem, scientists searched for a systematic way to organize their knowledge by classifying the elements. So we will be discussing about the different classifications of elements. First, Dobereiner's Triads, then ABD-Changadoy's cylindrical table of elements, then Newland's law of octaves, and finally Mendeleev's periodic table. So first, in this video, we will be discussing about Dobereiner's law of triads. It was in 1829 that Dobereiner noted similarity in physical and chemical properties among several group of three elements. Group of three elements are known as triads. So he found that the atomic weight of the middle element is approximately equal to average of the atomic weights of the other two. And the properties of the middle element were in between those of the other two members. So, these are the Dobereiner's triads: lithium, sodium, potassium, calcium, strontium, barium, chlorine, bromine, iodine. So, here we can see the atomic weight of lithium is 7 and atomic weight of potassium is 39. So, the sum of atomic weights of lithium and potassium will be 39 plus 7, that is 46. So, if we take the average, 46 by 2, it is 23, which is equal to the atomic weight of the middle element, that is sodium. Now, if we consider the second series of elements, that is calcium, strontium and barium, the atomic weight of calcium is 40 and that of barium is 137. So, if we take the sum of these two, 137 plus 40 is equal to 177. And if we take the average, it is 88.5, which is approximately equal to 88, that is the atomic weight of strontium. And if we consider chlorine, bromine and iodine, the atomic weight of chlorine is 35.5 and that of iodine is 127. So the sum of atomic weights of chlorine and iodine is 162.5. And if we take the average, 162.5 divided by 2, it comes around 81.25, which is approximately equal to 80. That is the atomic weight of bromine. Now coming to other triads that are derived by Dobereiner's: sulfur, selenium and tellurium, and iron, cobalt, nickel. In all these cases, the atomic masses of the middle element will be approximately equal to the average of atomic masses of the other two elements. This is followed in all the cases. Now, what are the flaws or demerits of Dobereiner's law of triads? The identification of new elements made this model obsolete. That is, by the identification of new elements, this model proved wrong. Newly discovered elements did not fit into the triads. Only a total of 5 Dobereiner's triads, as we have seen here, could be identified. Even several known elements did not fit into any of the triads. We know that Dobereiner's law of triads was introduced in 1829. Only around 30 something elements were discovered at that time. So even those 30 elements could not fit into the triads. Only 5 set of Dobereiner's triads could be identified. So this is why Dobereiner's law of triads was disqualified. Now coming to some problems based on the Dobereiner's law of triads. The first question: those in a group that falls under the law of triads include chlorine, bromine, iodine, 2. Carbon, nitrogen, oxygen, 3. Sodium, potassium, rubidium. 4. Hydrogen, oxygen, nitrogen. So, we have seen the group of triads that are introduced by Dobereiner in our previous slides. So, based on that, we can conclude that chlorine, bromine and iodine falls under the law of triads that is described by Dobereiner. Now coming to the second question, three elements X, Y and Z form a Dobereiner triad. Their atomic weights are in the ratio 5:11:17. If the sum of atomic weights of extreme elements is 176, then find the atomic weights of X, Y and Z. And options are given. Option A, X equal to 40, Y equal to 80, Z equal to 176. Option B, X equal to 40, Y equal to 88 and Z equal to 136. Option C, X equal to 40, Y equal to 80 and Z equal to 120. And option D, X equal to 80, Y equal to 100 and Z equal to 120. So how can we find the atomic weights of X, Y and Z using the given data? So here we are given atomic weights are in the ratio 5:11:17. So their atomic weights can be written like 5x, 11x and 17x. So, they are given if the sum of atomic weights of extreme elements is 176. So, the extreme elements, that is X and Z. So, their sum of atomic weights, it will be 5x plus 17x, that is equal to 176. So 22x equal to 176. Therefore x equal to 176 divided by 22. 176 by 22 is 8. So, what will be the atomic weight of X? Atomic weight of X will be 5x, that is 5 into value of X is 8. So, 5 into 8, 40. So, atomic weight of X is 40. Then, that of Y will be 11 into 8. That will be 88. And that of Z will be 17 into 8. That will be 136. So, the correct option will be option B, where X equal to 40, Y equal to 88 and Z equal to 136. Now coming to the third question, the three elements calcium, strontium and barium form a triad. What is the basis of this grouping? Elements are in the increasing order of atomic weights. The atomic weight of the middle element is equal to average of atomic weight of extreme elements. Elements in a triad have similar chemical properties. Option A given, only 1 and 2 are correct. Option B given, only 2 and 3 are correct. Option C given, only 1 and 3 are correct. And option D given, 1, 2 and 3 are correct. So, if we see the properties that are given again, elements are in the increasing order of their atomic weights. So, it is true in case of triads. The atomic weight of the middle element is equal to average of the atomic weight of the extreme elements. It is also true if we consider the triads. Elements in a triad have similar chemical properties. It is having similar chemical and physical properties, so it is also correct. So, the correct option will be 1, 2 and 3. These three are the basis of this grouping of elements into triads. Now coming to the question number 4. Chlorine, bromine, iodine follows Dobereiner's triads. The atomic masses of chlorine and iodine are 35.5 and 127 respectively. The atomic mass of bromine is. So we have to find the atomic mass of bromine. So according to Dobereiner's triad, the atomic weight of the middle element, that is bromine, will be the average of the atomic weight of the extreme elements, that is chlorine and iodine. So we should take the average of the atomic masses of chlorine and iodine, 35.5 plus 127 divided by 2. So we will be getting an answer which is equal to 81.25. So the atomic mass of bromine will be 81.25. Now coming towards the last question. In a triad of A, B, C elements, if the atomic masses of A and C respectively are 100 and 200, then the atomic mass of B is. So here they have given A, B and C are elements that are forming a triad. So here the atomic mass of the middle element, that is B, will be the average of atomic mass of A and C. So here the atomic mass of A and C are given as 100 and 200 respectively. So the atomic mass of B will be 100 plus 200 divided by 2, which is equal to 300 by 2, that is 150. I hope this is clear for everyone. If you are having any doubt regarding Dobereiner's law of triads, feel free to ask in the comment section. If you like this video, please like, share and subscribe. Thank you.